photos and the cost calculations, which is understandable without the knowledge of German. So the question is, why do we need the cooperatives? And they will play an important role in the decentralized expansion of renewable local heating networks. The reasons are first that many projects cannot be implemented because private companies and public utilities have to achieve a high return, and many projects also need a minimum size to cover the overheads of companies. Second is the pool, the capital of private individuals, and thus open another source of finance for achieving the energy transition. This is very important because if no contractor or no utility will invest, so you have to find another source of financing. They have a regional orientation and a co-determination, which is important success factor that promote acceptance. Also, it is a democratic participation of all the members, and there's only one disadvantage. We have to note the risk of bankruptcy. So this is the slide I wanted to tell you at the beginning. We have so-called BioEnergy Tübingen, and it is managed by a board, and Mr. Gammerdinger, who is in our regional stakeholder advisory group, is a member of this board, and also Mr. Kannenberg is member of the board. Each of us is constrained by our professional requirements. Günter Gammerdinger was board of a bank and has a lot of experiences in financing and in risk analysis. And now he's independent consultant who has specialized in developing renewable heat networks. So Harold has shown us his sensitive analysis and told us every economic calculation has uncertainties. So the exciting question is whether the financing bank believe the numbers and trust the calculation. So we expect that we try to arrange a webinar later in the project together with Intec and Harold, and we will show them some examples in the view of a bank member. Also, Wilfried Kannenberg, he's in his job the Chief Technical Manager of Municipal Utility of Tübingen. And in his job, he has to achieve return of investment. And also, he has the application of standards, and many standards that make sense in larger cities lead to financial knockout in small projects. So everybody has some functions in the developing of small heating networks. So and if you want to develop these networks, you need some success factors. The most important is that you will find at the start a nucleus, either municipal cooperatives or local companies with high heat requirements. And also it is essential to reduce costs through energy. In Germany now, it is very important to make a new high-speed phone network, the so-called 5G network, and also have a look on the renewal and the repair of water pipes, power lines, and sewage pipes. It is very important because it needs coordination, and sometimes it is really silly if you renew the sewage pipes and 1 year later you will develop the idea to make a renewable heating network. And then it is very important to make a sightseeing tour to converted biovillages. The people want to see how it can be worked. And it is also very important to have a target group specific addressing of homeowners based on life experience. And also later it is necessary to make an individual approach to homeowners. Günter Gammertinger said it's a kind of house warfare to overcome the sluggish decision and the laziness of the people. I will show it what I've said in one picture and slide. We have the town of MEHRSTETTEN. It's in the east of our region with about less than 2,000 inhabitants. It's the smallest village we have in our region. And on the right side, you can see the so-called nucleus, what I told before. It's a town hall, a school, and public buildings. And at the beginning here, you can look to get private buildings into the network. And a lot of presentations start with the question, is there any oil in MEHRSTETTEN? And of course the answer is no. And then you can tell the possibilities of wood chips and solar district heatings. And also the question where to find a good place to build it. It's called on the right hand Standortheizzentrale. And also the next problem is the political question. On the left hand, you can see the district of CROATIA, and they want to be there too, but poorly economically, it's difficult. Remember the precise sensitive analysis of Harold. Economically, it is really difficult, but it would not work if these people of CROATIA will not be together with the town, with the village of MEHRSTETTEN. And the big advantage is that they will develop the high-speed phone network this year and will build a new network through the town. And so they have to make to make infrastructure investments, and we can use this synergy for developing the regional network for heating. And what we have learned, it is in the next two slides. We have to find an individual implementation solution that must found for every bioenergy village. Based on the engagement of the stakeholders group in the village, the operator structures and the selected operator companies differ. The heat pricing is based on individual village-specific pattern. The full cost of heat supply in all villages is below the full cost of fossil heat supply fuel base. And for a successful implementation of bioenergy villages, sufficient agricultural and renewable resources, a compact village structure, a suitable conserve location for the energy system, and social skills are important and essential. And social skills are a good village community. You have to establish an identity, feeling of belonging. The actors who enjoy the trust of the population and drive the project forward. And you need also community representatives who support the project. And it is needed a transparent, open-ended planning and implementation of the project in which the citizens are creative and can participate financially. And also the participants' inner conviction that only suitable solutions are sustainable in the long term is very essential, because we have always heard about the situation that oil is cheaper now due to the situation we have and so on, but this is not correct in our view. You have only to see a very long-term development. Thank you for your attention. So, are there any questions?
Questions? So,
this is Johanna speaking. Can you hear me?
yes.
I have one remark from yesterday's discussion. I understood that in Eastern European countries, this cooperative model that has been hyped very much in Germany in the last years is not very well liked, probably to this post-Soviet legacy. So I would like to discuss a little bit whether there are alternatives, like this Polish model of energy clusters, to create this kind of community energy.
Okay. You have a presentation? Do you have a presentation?
No, that was just like a question or a remark to discuss whether we can find alternatives for community energy instead of the classic cooperative model.
Difficult too, but maybe Matteo and Ape Friuli can add something about that, but
Well, on our side, we have positive examples concerning energy cooperatives in the Alpine states. Let's say that in the northern part of Italy, these cooperatives were established almost a century ago, because in the Alpine areas, let's say big companies were not so interested in investing money to develop the infrastructure. So basically now, these have been successful examples in the energy sector, because they have different objectives. So basically they sell energy at a lower price to the members, and they are welcomed by local communities. On the other hand, especially in the last years, in the last decade, we had examples of cooperatives that went bankrupt, with a lot of consequences for local communities. So it's difficult to say. It depends from the single cooperative. Some of them are successful and welcome, and the other ones are problematic. Competent people are important within this subject.
Also good communicator, and also it depends as for Italy on the area, and it's quite a cultural problem also. Could be also a cultural problem, just not to trust the neighbor or the other. So it's not such a easy issue just to face in some part of Italy, but in some northern areas it could work, in my opinion.
Thank you for your interesting inputs concerning energy cooperatives. I think it's a good idea to move to the next presentation. So to move to the part of Patrick Geiger. This is possible, yes. So that you stay in time, and then we can go on discussing. Thank you.
Please share your screen. You are ready.
Yes.
Okay.
Thank you, Chiara. It works. So, all right. So I will tell you now something a little bit about the economic feasibility of solar thermal plants. I'm from Solitas in Stuttgart. We are a research institute, especially for solar thermal plants, big solar thermal plants. So I think I can give a good look about the topic. So I will start with the calculation of the economic feasibility of such solar thermal plants, give a little overview about the cost types and the key figures, and at the end I will give you a short example calculation and some important influencing factors. So at the beginning, it's important that large-scale solar thermal plants, that the economic feasibility is usually assessed on the basis of the heat production cost. So the heat production costs are the annual total costs, of the complete plant divided by the annual amount of solar heating feed into the district heating network. Actual or current, we can reach for larger plants costs around about 50 euro per megawatt hour. With subsidies in Germany, there are costs of 30 euro per megawatt hour possible at this time. The heat production costs are calculated with the annuity method of according to the VDE 2067, which Harald has also said that they calculate of these costs, and the heat production costs incurred are broken down into some different costs. So at first there are capital costs and the operational costs also, and then are the demand related costs, and some other costs are included too. Normally we calculate over an observation period of 25 years. So this is a long term, but it's a high investment, so it's a good thing to look at a long time. In additional, the capital interest rate and price increase factors are also taken into account. The price increase factors usually approximately between 1 and 3%, and this will be account to the operating electricity for the reinvest and so on. Further, we consider the replacement per case. You see it in this graph. We have just a moment, I will get the laser pointer. So we have a price for the component increasing from the initial value, the A0, according to the price factor, price increasing factor. And after the end of the use period, Tn, the replacement period becomes necessary. So this replacement has the net present value A1 at the beginning of the period under review, and after a second replacement is also discounted to the present value A2, and in the end the residual value of the component is calculated accordingly. So there are some parts in the plant who has to replacement in the period of 25 years. So we consider this in our calculations. Okay, so now we come to the short overview about the cost types and the key figures. The first are the capital costs. This is the investment, and solar thermal systems are very capital intensive projects. We will see this in this chart. This is a comparison between a fossil boiler, the blue lines, and the solar systems, the orange lines. Beginning with the fossil boiler, you see the annuated investment of the fossil boiler on the blue line down there. It's a very low investment, but when you look at the operating and the maintenance costs, also annuated, they will increase in the using time very much. And in the sum, we have a very high annuated costs over 15 years in this case. When we now look at the solar thermal invest, this is much higher than the investment costs of the fossil boiler. But when we look at the operating and the maintenance cost, they are very low. And so the increase of the total costs of the solar thermal are very low over 15 years. And in this case, around 8 years, the costs of the fossil boiler will turn over the costs of the solar thermal. Okay. Further the capital costs, the heat generation costs of a large scale solar thermal plant are primarily determined by the investment cost. We've seen it before. And capital costs, the investment costs, split up into some different components. There are a big point are the collectors, the solar collectors. There are two different types, flat plate collector and the vacuum tube collectors. Then you have normally heat storage. Then you have plant energy, like the transfer station to the district heating, for example. Then you have the building for the heating systems. This is all often combined with the building for other heating systems, like the biomass boiler, for example. And you have also measurement, control, and regulation technologies. Very important point is the ground you need for large-scale solar thermal plants. Big grounds, big land areas to build up the solar thermal plant, and you also have to consider the planning and approval into your calculation. But for the capital cost, there are significant economics of scales in the costs of the main components. The main components are the collector and the heat storage. So as bigger your collector area, as lower your specific costs in Europe per square meter for the collector area. The same is for the heat storage. As bigger the storage tank per cubic meter, as lower the specific costs for the storage volume are. For example, in this graph down, you see the costs on the left side and the area on the X side, and you see that with the increasing collector area, the specific costs decrease. Further, to estimate the capital costs, are different approaches for the collectors. the determination via a cost curve, like we see before, or also price queries are possible. The same for the heat storage tank. We have also a cost curve for the heat storage prices, and also you can do some price queries with to utilities to have a concrete price. Also, for the blend technology, we approximately take 7% surcharge on the main component costs. And also for the buildings, we approximately showcase on the main components. And the same for the measurement and control technologies. They also showcase on the main components. For the planning, we must look at the integration of the solar thermal. We have a decentralized or a centralized integration, and depend on this, we have 5 or 10% surcharge on the total costs for the investment. Now, further important boundary conditions are the useful life of the various components and the cost of repair and maintenance. We also consider this. These are some standard value which we use, but depend on the project. You have to vary this. So it's just a standard value for us. Further are some the demand-related costs. In the blend operation, the running cost relative low. So for the solar thermal, you have no fuels are required. Only the operating current is needed, around about 1 to 2% of the solar thermal useful heat yield per year. And so this means that the heat production costs are very stable for solar thermal, and the advantage is that the costs are known from the first day of operation for the next 25 years. So I will now show you a little example calculation. We have some basic data. We took a collector field with 10,000 square meters, high temperature plate collectors, integrated centrally in a district heating network. We have a heat storage with 700 cubic meters, and we have a solar useful heat yield about 3,300 megawatt hours per year. There are some calculation data for the field, and the district heating requirement of 60 gigawatt hours per year. It's a bigger district heating network, and the connection to the district heating and the property costs are not taken into account to this calculation. When we look at the costs, we calculate with the cost curve for the collector field. We have investment cost around about 2.2 million euros. For the heat storage, also via cost curve, we have costs about 230,000 euros, and with the further costs for blend engineering, building, measurement and control technologies, and planning, we have investment cost only for the solar thermal plant without subsidies around about 9.5 million euro. When we now look at some subsidies for Germany. There are different programs to get subsidies. In this case, we have took the KfW program, Renewable Energy Premium, and in this case, we take the larger enterprises. So you have a subsidy rate about 45%, and so the investment costs decrease with subsidies of around 1.6 million euro. In conclusion, you see the investment cost without and with subsidies. Then we annualized the total investment costs with the use of electricity auxiliary power, with the maintenance and operating costs over an observation period of 25 years. And at the end, we get total annual costs without subsidies of 210,000 euro per year, and with subsidies for larger enterprise, in this case, around about 128,000 euro per year. And now, in the next step, we will calculate the heat production cost, take the total annual costs and divide it by the heat production, in this case 3,300 megawatt hour per year, and we get a price rate or the heat production cost range from 39 euro per megawatt hour with subsidies and 64 euro per megawatt hour without subsidies. So this is a real case, and these are real costs, and so it's good costs for the solar terminal are necessary to achieve them. So next are some influencing factors for the heat production costs. So first, the interest rate has a great influence on the annual capital costs and thus on the heat production costs. And it's dependent on the internal interest rate applied, depending on the company. So cooperatives has less interest rated, and for example, a utility has a higher interest rate maybe, and also it's depend on the capital market. So the funding through borrowed capital, for example, has a great influence to the annual capital costs.
Hello, Patrick. You only have a few more minutes left for your presentation.
Okay. All right. So the next big point for the costs are the land acquisition costs and the realization of distributed or roof integrated collector areas increase the costs. So a land-side solar terminal is much cheaper than roof integrated collectors. The next point is the higher solar fraction usually requires a more complex system and storage technology, and at the same time lower specific system yields are achieved. And also the duration of calculation is important. So if you have 3, 10 or 25 years, but the basis for the calculated costs allocation is normal useful life of the asset. So 25 years for large solar systems are a good duration of calculation. And then, so large-scale solar thermal systems are an economical alternative. The essential prerequisites for favorable heat production costs are a sufficient plant size, so it should be bigger than 1 megawatt thermal. The simple plant technology. As I said, the open land installation is much cheaper than roof-mounted collectors, and a suitable heat network temperature is also important for good working solar thermal systems. So, as said at the beginning, for larger systems, the heat production cost of around 50 euro per megawatt hour are achieved. And with subsidies in Germany, we can arrive around about 30 euro per megawatt for heat production costs. And for further information on this topic, you can also visit our homepage, solardistrictheating.eu. There you find a lot of further information around about solar thermal systems. You find some best practice examples and so on. So thank you for attention and goodbye.
Thank you so much, Patrick.
Thank you, Patrick, for showing us a simple calculation for solar thermal systems. Are there any questions which needs to be answered now? If not, we can move to the next presentation of Heidrun Kögler and also of our project partners from the DACHET regions who will tell you something about funding in the ENTRAIN regions.
So, Heidrun, is that right?
Yeah.
Okay. Here you are. Please. Heidrun, you can start. Thank you. We can see. We can't hear you.
Oh, okay.
Now yes, we can hear.
Great. Sorry. Yeah, now we're going to talk about fundings of renewable district heating systems. First, we will explain how the funding works in Austria and Germany in detail, and then we want also to ask you to say a few words about the funding schemes in the other target countries. Okay. So the first question that arises is, why does it make sense to support renewable district heating systems with financial incentives of the government? The first reason is that they make a huge contribution to the global and EU-wide aim of decarbonization of our heating sector. Furthermore, district heating systems have a highly positive effect on creating local jobs, and also they increase the added value in regions where they are implemented. Of course, this only makes sense if some requirements are fixed and fulfilled. So it is important to introduce some criteria which ensures that emission limit values are met and district heating systems are efficiently operated. Furthermore, the plant should be operated economically sustainable, which mainly includes the fuel supply from regional forests. In Austria, it could be demonstrated that the operation of biomass-based heating systems increases the added value for the economy and creates many jobs in the biomass sector. This is true especially in structurally weak regions. Moreover, energy imports and capital outflow are reduced. As a result, the BADE grants from the government turn out to be profitable in just a few years, and so there is a big benefit for the Austrian economy. Here you can see a short overview of the Austrian funding systems for renewable district heating systems. The funding system for renewable district heating systems. First, there are investment fundings on the operator side, especially here in Austria, the MEHRSTETTEN, which is obligatory to get investment subsidies and which guarantees a special quality of the realization. Second, the consolidation of older biomass district heating systems is strengthened. And third, there are subsidies for customers who want to connect to a district heating system. So let's have a look on the investment fundings which concern the operator side. These fundings consist of a one-time non-refundable investment grant for operators and district heating systems. It is processed by the Kommunalkredit Public Consulting, which is a funding agency in Austria that consults applicants, accepts funding applications, and also checks the eligibility of the projects. Considering the motivation effect of these fundings, the application must be handed in on an online platform before the start of the project. This means before the first legally binding order. Eligible are companies, other entrepreneurial organizations, associations and cooperatives, and religious denominations. The funding is only provided for projects whose investment costs exceed 10,000 euros. In case of geothermal heating plants it has to exceed 35,000 euros. Also, CO2 emission savings must be at least 4 tons per year. And for all investment grants, an additional funding is possible. Additional 5% are possible for EMAS certified companies. EMAS is an eco-management audit scheme which is granted to audited companies. And another additional 5% are granted for additional sustainability measures. One condition is the use of industrial waste heat. Another condition is that at least 80% of the used wood must be gained from regional forests within a radius of 50 kilometers. This funding concerns the following investments or measures on the operator side. You see here a very detailed descriptions. Unfortunately, we don't have the time to go into it in detail, so I will just give you a quick overview. Funding are first new biomass heating plants and heating grids. They are defined as grids with heat supply for at least 2 separate special objects and 2 different owners. Second, the expansion of already existing heating grids based on biomass, geothermal or industrial waste heat. Third, the optimization of existing heating plants and networks. Included are measures for the optimization of the district heating system to reduce the fuel input. Fourth, the renewal of boilers in existing biomass district heating systems. Fifth, the biomass cogeneration heating plants with or without distribution grids. Sixth, the geothermal heating plants for individual customers of the district heating system. And seventh, the densification of renewable heating plants and networks. As you already know, one special thing in Austria is the Heizwerke, which is obligatory to get investment subsidies for district heating plants with a nominal boiler load greater or equal to 400 kilowatt hours and or a district heating route length of greater than or equal to 1,000 meters. Smaller district heating systems are subject to the quality management for smaller systems, which is named Compact. This concerns new heating plants and networks as well as their enlargement. The high quality and efficiency requirement of the Heizwerke and the funding criteria of the environmental support guarantee a sustainable and efficient utilization of the granted funds. That is why the Austrian funding system was even recommended by the European Court of Auditors in one special report. The second funding concerns the consolidation of older biomass district heating systems, which is also a funding for operators. More than 30 years ago, the first of more than 2,400 biomass heating plants and district heating systems were built in Austria. Since then, the state of art has developed significantly. So, with targeted advice from experts regarding optimization and modernization, older plants are supported to bring them up to date of the latest technology. The implementation takes place within the frame of a cooperation of MEHRSTETTEN and the Economic Initiative of Sustainability, called WIN. The advice concerns the modernization and renewal of plant components, the continuation of the optimization of plants, the potential expansion and densification of the heating plant and the grid, and the integration of other renewable heating sources such as solar thermal energy or waste heat. One condition to get the subsidy is that the district heating plant has to be older than 20 years. Included is a maximum of 80 hours of consultancy. This means a total value of the advisory package of 3,200 euros. A maximum of 50% of it is funded. And there is also the possibility to start with one nearly cost-free startup consultation before. Also, a list of available quality managers of MEHRSTETTEN can be found online. Now, the third funding of district heating systems in Austria that I want to mention is the subsidy of customer side, on customer side. At first, some general information about it. In Austria, the funding for customers of biomass-based district heating systems is different in each federal state. So I will only show the situation in STYRIA. In STYRIA, the funding is situated at the Division 15 called Energy and Housing. The funding is reserved for tenants, owners, or property management of houses or flats. District heating connections are eligible for the subsidy if changing from existing individual heating systems or for new buildings of 1 or 2 family houses. The general funding requirements are no other fundings from federal state agencies of STYRIA are allowed for the same project. There must be corresponding agreements between the operator of the district heating system and the land of STYRIA. Both sides support additional connections with a financial incentive. The district heating system has to be completely or partially, at least 80%, built of sources of renewable energy, of highly efficient cogeneration plants, or of other waste heat, which otherwise remains unused. Starting with the date of commissioning, customers have to commit to obtain their heating energy for at least 3 years from the district heating system. In this table, you can see the funding rates of the different for different circumstances. For example, you see here in 1 or 2 family houses, the grant of both the land STYRIA and the operator of a district heating system is 600 euros for one district heating connection. So the total grant for one connection is 1,200 euros. The same is true for new buildings. For apartments, different grants are funded. Yeah, this is the end of my presentation about the Austrian fundings for district heating systems. And now I want to ask Patrick again, Patrick Geiger from Solides, for his presentation about the funding system for the renewable district heating systems in Germany. I already included all slides in my presentation, so if it's okay for you, I will continue the presentation and switch the pages for you.
Yeah, I think it's okay.
Is okay, or do you want to?
No, I think it's okay.
Great.
Only 4 slides, so thank you, Heidrun, for the introduction. So I will give you a little overview about the funding possibilities in Germany. Please click to the next slide. Thank you. So we have some different funding programs in Germany. They are all more or less complicated, and so I will just give a little overview about this. The first I would start is the so-called heating network systems 4.0, in Germany Wärmenetzsysteme 4.0. And the main topic is the funding of innovative total systems. So they are the look of the complete system, that not only of one lonely part. And the funding is what would be give to a feasibility study, to implementation costs, also to information measures and cooperation with scientific institutes. There are some boundary conditions for the district heating, for example, that depend on the supply temperature. You have also boundary conditions to the producer structure. So you have mainly used renewable energy systems, but also you have a maximum of 50% of biomass, so that the innovative factor is implemented in this. Founding level is in this case a maximum of 50% and limited on 15 million euro per project, and it's investment grant. Next slide, please. And also I have the links to the funding programs in each slide implemented. So you can click on this when you want further information. The next one is the market incentives program from the KfW bank. It's a bank group for funding different things, so also renewable energies, and they funding investments on district heating, funding on large heat storage and large renewable energy sources. So for example, different renewables like biomass, heat pumps, solar thermal energy, investments, they're funding investments into new heat networks with 20 euro per kilowatt thermal energy, but maximum of 1 million euro. They funding the investment of the house transfer stations and for thermal storage from 10 cubic meters, and also for central heat pumps. But there you have to reach a minimum COP of 3.8. So further various requirements for renewable energy shares, connected buildings, and so on. And it's funding in a loan with a repayment subsidy of some percents. Okay. The next one is a CHP law, or the funding about the innovative CHP systems. The process is a tender for plants between 1 and 50 megawatt. For the rest, you have fixed charges for the remaining plants, lower than 1 megawatt and higher than 50 megawatt. And for the renewable energies, you can use the innovative CHP systems, also with a tender with 3 mandatory components. They are a high efficient new or modernized CHP plant. You have planned innovative renewable heat source like solar thermal, geothermal, or a heat pump, which have a minimum of 30% of the reference heat. And the third thing is you have to blend. Oops. Yes, thank you. The third thing is the next slide, please, Heidrun. Yes, thank you. All right. The third thing is for the mandatory system, an electric heat generator, like an electrode boiler or electric auxiliary heat. For this part, you can't use the heat pump. The heat pump is only for the innovative renewable heat. So the electric heat generator must be one of the 2 electro boiler or auxiliary heating systems. In the table down, I have built up some the results of the tendering from the last 2 rounds, and you see the average quantity rate surcharge value was about 11 cent per kilowatt hour you get when you get the awarded to the innovative CHP. Okay, thank you. Next slide, please. And now this is one funding program for district heating only in Baden-Württemberg. It's a region land in Germany. This is additional to the federal funding, but only in Baden-Württemberg available, and the funding is goes to investments for new or expansion, new district heating or expansion of energy efficient district heating, and you have to use renewable energy sources or high efficiency CHP plants. Additional, there are different bonuses possible. For example, you get more for using solar thermal, for using waste heat, for using large heat storages, or when you reduce the return flow temperature of the grid, you get 20 for the bonuses. You get 50,000 euro per bonus on top, so a maximum of 400,000. And for the investment of the into the district heating and plants, you get a maximum of 20% and a maximum 200. And finally, you can get a maximum funding rate of 400,000 euro per project. Okay, thank you. I think this was it. This short overview about the complex system, funding system in Germany.
Great, thank you, Patrick.
Thank you.
You're welcome.
Now we will come to the funding system of Croatia. I think Eva will present it. Eva Dutanovsky from the Energy Agency of Northwest Croatia. Are you here?
Hi, yeah, I'm here. Hi. Thank you for announcing me. I'll be really brief and short because there are no available funding for renewable district heating systems in Croatia. Actually, there are no available funding for district heating systems in Croatia at all, not only renewable ones. But here's just an overview. Pokupsko district heating system is the first communal biomass district heating system in Croatia. It was commissioned in late 2015, and I believe it was the last biomass district heating system which was funded through grants or subsidies. In this case, it was financed by the EU's instrument for pre-accession assistance in rural development as well as by the Croatian Environment Protection and Energy Efficiency Fund. This project started before Croatia entered EU, so that's why it was funded by the EPARD instrument. The system has the capacity of 1 megawatt, and the district heating network is 1.2 kilometers long. It supplies around 30 users through individual substations, which includes public buildings such as elementary school, municipality, administrative building, church building, but also some houses and local utilities. The plant is fueled on locally available wood chips originating from the surrounding forests and residues from local sawmills. Yes, annual heat generation of the plant is up to 1200 megawatt hours. And yes, as I already mentioned, this was to my knowledge, the last renewable district heating system financed through subsidies. As already mentioned, there are no funding available for renewable district heating systems. Only individual renewable heating systems in houses or multi-apartment buildings are incentivized via national or county subsidies. These usually go up to 50% of the investment, but I think the limit financial-wise is around 5,000 to 7,000 euros, if I'm not mistaken. Yes, co-financing of renewable district heating system is currently not available in this programming period, which was 2014-2020, because vast majority of the subsidies actually come from the EU grants, which have to be programmed into the operational program, which is determined for a 6-year period. But we are hoping that the renewable and especially biomass powered district heating systems will be included in the draft of the strategic document for the next programming period, which is being developed by the Ministry of Agriculture Working Group, of which Rega is part of. Yes, and this is just a mention of the Horizon 2020 Keep Warm project, with whom we are collaborating, because they are developing projects such as Keep Warm and ENTRAIN they are working on initializing investments and trying to find the subsidies or actually encourage governments to provide subsidies for renewable district heating systems, and that's why the Keep Warm project is mentioned, because they did some cost-benefit analysis for integrating solar energy into this is a mistake. It wasn't Zagreb, the district heating system, but surrounding towns, Zagreb surrounding towns. There was 3 of them, and they did cost-benefit analysis of for those cities, which is also it's a step forward, but a lot has to be done in order to get these renewable district heating systems incentivized in Croatia, as currently there are none, and there are no incentives. And that is it from me about Croatia.
Great, thank you, Eva.
Thank you.
We will continue now with the fundings of renewable district heating systems in Italy. Matteo will continue. Matteo Mazzolini from the Energy Management Agency from Friuli Venezia Giulia.
Okay, thank you. Next one, please. Yeah. Here in Italy, we can divide between the national level and the regional level. At national level, there are available these tax credits for energy produced from renewable energy sources And here you can see the figures available for end user consumption. So there are different laws regulating these tax credits, and they are based on the final consumption. So suppliers of heat generated with renewable sources have access to this credit, and usually they transfer the credit to the final customers. Next one, please. Next slide, please.
Next slide.
I think my computer is slow.
Okay.
I already switched the slide, but you do not see it. No. Okay, now it should be.
Yes.
Going on.
Yes, we can. Okay.
Yeah. And concerning the situation at regional level, like in Austria, it's different from region to region, also in Italy. So what I'm presenting here is the situation in our region. And basically, as you can read, localization, promotion, and funding of district heating systems supplied with biomass is up to our region, and there is an annual code that usually is opened at the beginning of every solar year, and there public authorities can get up to 70% of eligible costs. So basically they have to provide a preliminary concept of what they are planning to develop at local level, and if the project is approved, then they can put in place the investment and get back the 70% of eligible costs, so rather high. And eligible measures regard the design of district heating system and or the extension of existing ones. And the maximum grant contribution is 800,000 euros. And that's it from our side. Adrian?
Thank you.
Okay.
It's up to Slovenia. I think so.
Sorry, my computer is really slow. I don't know why.
What?
Okay. Sorry.
Oh yeah, sorry, I forgot this one. The Rural Development Program for Venezia Giulia. Yeah, this is a structural fund available from the European Union. And basically here, all the value chain from the forest to the final user are subsidized with European funding. But particularly when the investment is developed by farmers in this case. So these are funding dedicated to farmers on one side or to rural communities like mountain communities in the Alps. I think now we have finished.
Yeah, thank you very much, Matteo. The next would be the funding the renewable district heating systems in Poland, and I think Anna Lachowicz should present it.
Yes, hello.
Hello, Anna. Welcome from the Association of Municipalities Polish Network Energy Cities. Please start.
Thank you. Next slide, please.
Yeah, it comes. Sorry.
Okay.
It's so slow.
How can we solve this?
Sorry, I don't know what happens. Can you hear me?
Yeah.
Maybe, yeah, Anna, if you can share your screen, if this is possible. I think maybe that's good.
I can make you.
Anna, do you have the slides?
Yeah. My first slide? No, no.
Do you have your presentation there so that I can share your screen?
Okay.
Okay. Anna, now your screen is
Not this, Anya.
I'm sorry.
No problem.
Anna Jakovic, that's right. Oh my God, I'm completely. Okay, is that right now?
Yes, yes.
Okay, you can share your screen. Oh.
Okay.
Thank you so much. Thank you to Adrian.
Do you see my screen?
Yeah, yeah.
Maybe.
Yes, we can see.
Wait a second. Okay. So you can see, all right?
Yes, yes. Perfect.
About funding opportunities for renewable district heating in Poland, the financing support is mainly implemented by the National Fund for Environmental Protection and Water Management Institute. And for years, the National Fund has been supporting projects aimed at modernization and optimization of heating system in Poland. Through integrating its activities into the implementation of both national and European Union objectives. And on the slide are two projects that have already been finished in last year. The first one is efficient heating and cooling system and was implemented with national resources. The objective of the program, this program was to support projects in an existing enterprise for the construction of generating units with the connection them to a distributing network in which at least 50% renewable energy or waste or 75% heat from cogeneration or 50% use a combination of such energy and heat is used to produce heat or cold. Co-financing was granted in the form of loans and subsidies in accordance with the priority program up to 85% of eligible cost. The second program was supporting for investment in producing of energy from renewable sources and connection of the sources to the grid distribution and transmission. And this program was implemented with European Union funds. The national funds at this moment of the Ministry of Environment and the Ministry of Investment and Development have announced three programs largely aimed at supporting the use of renewable energy in heating. These are the district heating program, Energy Plus, and Polish Geothermal Plus. The first two programs have very similar objectives. And this program focusing on reducing or avoiding harmful emission to the atmosphere, reducing the consumption of primary raw materials, improving energy efficiency, new heat and electricity sources, modernization of heat networking, and energy use of geothermal resources. And the third program, Polish Geothermal Plus, it's construction or modernization of heat plant or combined heat and power plant based on geothermal sources. And application to participate in this free program may be submitted until December 2020. And the beneficiary in the first program in district heating are companies whose objects of activity is the produce of heat for municipal and household purpose. And the second two programs, the beneficiary are the entrepreneurs engaged in business activity. Also, co-financing is granted in the form of loans and subsidies in accordance with the priority program. Also, if local governments are interested in developing heating system using RES, they can take advantage of bank grants and loans. For example, at this moment, attractive loans for pro-environmental projects are offered by a bank for environmental protection in Poland. Also, or funds from private investor, for example, public-private partnership or energy communities. Next slide. Also, regarding the government support, in Poland operate the energy cluster, and this is there are a specific type of local energy communities, and their establishment is promoted and supporting by the government. They make possible to coverage of local energy damage by use of local sources, local renewable energy sources, and as a result contribute to increasing local energy security, energy safety. Therefore, in our target region works the Płoński Energy Cluster. The provision in the current RES Act in Poland unfortunately don't meet expectation regarding the possibility of a broad development of heat produced from RES. And from my side, that's all.
Okay, great. Thank you. Thank you very much, Anna.
Thank you very much.
We can now try.
Okay.
Yeah, you want to switch to the ERST and I Intec presenter again, because now I changed to this other computer.
Oh, great.
Chiara or Anna, maybe can you give me the moderator?
Oh.
The presenter of
Hello, everybody. Can you hear
Chiara?
me? Yes.
Can you switch the moderator role to the presenter of ERST and IAE?
To
the presenter.
I can't understand you. Sorry, something got wrong.
Can you switch the moderator back to the presenter of ERST and IAE?
Oh, okay.
Please.
Thank you. Sorry. Here we are.
Because the presentation.
Okay.
From about the fundings of renewable district heating systems in Slovenia, and I think nice Jurko from Xena will present.
I need yes.
Great. So please 3 minutes.
Okay, I'll be very short. So yes, we have fundings possibility for renewable district heating system. This is the scheme from our Ministry of Infrastructure. year or a year and a half ago, they published a tender for co-financing of district heating on renewable energy sources with a budget of 20 million euros with possible increasement. There is this is for all kind of renewables, so they're targeting most on biomass, solar, geothermal, and so on. So the eligible for applications are companies and cooperatives. The co-funding amount depends on the size of the company. So for small companies, there are 55% of for eligible costs. For medium-sized companies, up to 45% of eligible costs, and for big companies, up to 35% of eligible cost. So you need, if you want to get these funds, you need an investment program, design documentation. You have to provide the public procurement procedure. So you have to select the supplier of new boiler or equipment and everything. And after that, you fulfill the application form and you get your approval in a couple of months. As I mentioned yesterday, when I was talking with people from ministry, there is still a lot of funds available in this scheme. So yes, next slide, please. Okay. The second possibility is funds for residential use, so to connect the district heating system. So residential can get a subsidy of up to 50%. This is co-financed by Slovenian EcoFund. The Slovenian EcoFund also co-financing the new biomass boilers or heat pumps or solar collectors, I believe, also for residential use. So this is for residential or for small size companies. And the third option for financing, next slide, is this is, as mentioned, this is the grants from Ministry of Infrastructure and Eco Funds, and there are also possibility to get the loans from Eco Fund for your sustainable investment in renewable energy sources. Regarding larger entities, larger district heating systems, you have feed-ins for cogeneration on, so combined heat and power generation. So this is the scheme that is run by Slovene Energy Agency, and the latest prices are only for electricity. So you get the subsidy only for produced electricity, not for heat. So you have to sell your heat on the market, and the price is up to 170 euro per megawatt hour for small applications. So for smaller boilers up to 50 kilowatts, 155 for up to 1 megawatt cogeneration plants, and 152 for up to 10 megawatt cogeneration plants. You have also support for fuel-based cogeneration. So fossil fuel-based generation, this is obviously on natural gas, and the subsidy or the feed-in is between 117 and 84 euro per megawatt hour, depends on the size of the plant. So basically, this is the fundings, possible fundings for Slovenia, in Slovenia. Thank you.
Great, thank you very much for the presentation. If it's okay for you, we would shorten the pause. Sorry for the technical problems before.
Don't worry.
Because we have another very interesting presentation from Siegfried Eigner after the last pause, and we would like to shorten the pause for 5 minutes, if it's okay for you. So we would need
At 12:15.
12:15 again here.
Yeah.
Please.
5 minutes. Thank you so much.